Today let's see about how to calculate a bending stress for a cantilever beam of length L will with constant load P applied at the free end. So here you can see the length of the cantilever beam is 5 meter. Applied force at the free end P equal to 10 kilonewton, F equal to 10 kilonewton. We can say this as F. This example is for a junior to understand how the bending stress is calculated in a cantilever beam. The dimensions of rectangular cross section. This beam's rectangular cross section dimensions are given B 100 mm, H 200 mm. First step is calculate the bending moment at the fixed end. So we have to calculate the bending moment at this fixed end. So this is the force F into distance. So it will vary the bending moment. This is the bending moment diagram. So the maximum moment is F into L. For a cantilever with a point load at free end, the bending moment at a fixed end where the beam is fixed is calculated by M equal to F by L. F we know, L also we know. So M equal to 10,000 Newton into 5 meter. That's 50,000 Newton meter. Bending moment at the fixed end is 50,000 Newton meter. Now let's calculate the moment of inertia for rectangular section. Second step is calculating the moment of inertia for the rectangular cross section. The moment of inertia for rectangular cross section about central axis X is given by, this is the major axis. So X, this is the rectangular cross section. This is the X major axis. So moment about X that we have calculated it. Moment about X we have calculated just now. M equal to F into L is a moment. So here will be a tensile stresses, and this fiber it will be a compression stresses. It will come. This is the beam cross sectional area, right? This is the beam cross sectional area. So top fibers it will be the tensile stress, bottom will be the compressive stress. So we can see this amount of inertia about Ix is equal to the B is the width of the cross section. B is the width of the cross section, that is we know it's 100 mm, and H is the depth of the cross section. So I equal to BH cube by 12. So we can calculate the I value. The amount of inertia of rectangular cross section is 6.61 10 power minus 5 meter per 4. Step 3 is calculate the bending stress. The bending stress at the outermost fiber of the bottom of the beam is given by sigma equal to M times Y by I. Y, this we know the cross section of the beam. This is the beam, rectangular beam. So this is the cross section of the beam. So this is our x-axis, and y is nothing but the distance from the centroid of from this point from here to here. This is the distance. This is the y value. Here you can see y is the distance from the neutral axis to the outermost fiber, that is half of the height of the section. So we can know all these values. We can calculate the bending stress is 75 MPa. The bending stress of the beam is given by 75 MPa. The bending moment at fixed end is 50,000 Newton meter. Moment of inertia of rectangular cross section is 6.67 into 10 power minus 5. Bending stress is 75 MPa. Bending stress is the maximum stress experienced at the outermost fibers of the beam, which is crucial for designing the beam to prevent failure. Let's see one more example. In this example, same cantilever beam, the length equal to 5 meter, force is 10 kilonewton, but the diameter of the circular cross section, the beam cross section is circular, that is 200 mm we are getting it. So this is the beam, like example same as previous example. Load F is applied at 5 meter distance from the fixed end, and load value is 10 kilonewton, and the distance is 5 meter. But the cross section of the beam, this cross section of the cantilever beam is circular cross section. So circular cross section with 0.2 is the diameter. So we know the We know this is the x-axis. This is the x-axis. This is major axis, and moment of inertia we can calculate. That moment of inertia is nothing but I equal to pi d squared by 64, pi d power 4 by 64, pi d power 4 by 64. That's the moment of inertia for the rectangle circular cross section. So the steps, if you see, first we need to calculate the bending moment at the fixed end. Second step is calculate the moment of inertia of the circular cross section. Third step is calculate the bending stress. So how to calculate the bending moment? We know for a cantilever beam with the point load F at the free end, bending moment at the fixed end, that is where the beam is fixed, is M equal to F into L. So we substitute in the given values, we get the bending moment at the fixed end is 50,000 Newton meter. The same we calculate the moment of inertia of circular cross section. For circular cross section, the moment of inertia about the centroid axis is given by pi d power 4 by 64. Diameter we know. So substituting the values, we get this 7.8 in 10 power minus 5. The amount of inertia of circular cross section is 7.86 in 10 power 5. Next step is calculate the bending stress. Bending stress at the outermost fiber of the beam is given by M into Y by I. This we have seen. This is the circular cross section of the beam. Circular cross section of the beam. And then we know this axis, centroidal axis. We know the centroidal axis. From the centroidal axis, the outermost fiber also we know. This is the centroidal axis. Outermost fiber is, this is the distance. So that is half of the diameter. That's why O equal nothing but the distance from the neutral axis. Distance from the neutral axis to the outermost fiber, which is the radius of the circle. 500 meters. So amount of inertia we know. Those substituting these values, we get 63.69 MPa. The bending stress is given by 63.69. So 50,000 meter. And so 1.86 and bending stress 63. We can compare like the rectangular cross section and circular cross section of 0.2. Here the bending stress is less in circular cross section for this cantilever beam. So this is the discussion between the professor and the student. Good morning everyone. Today we will tackle the very interesting problem on cantilever beams. The challenge to calculate the bending moment and bending stress for a beam of circular cross section. Are you ready for it? And the students is telling that I always love practical applications. Professor, could you remind us the bending moment? Could you remind us about the bending moment formula for a cantilever beam? Of course, the bending moment at the fixed end of a cantilever beam is calculated using M equal to F by L. So we know the fixed end moment. The bending moment at the fixed end of the cantilever beam is calculated using F by L. M is the bending moment, F is the applied force at the free end, L is the length of the beam. Got it. But what about the moment of inertia for the beam's cross section? Since we have circular cross section, how does that affect our calculations? This is another student is asking question. Since we have the circular cross section, how does that affect our calculation? Yeah, Chris, I was hoping you would ask a question. You asked that. For a circular cross section, amount of inertia about the centroidal axis calculated using pi d power 4 by 64. D is the diameter of the circle. Okay, but once we have the amount of inertia, how do we proceed to find the bending stress? Once we have the amount of inertia, how do we proceed to find the bending stress? Great question, Olin. The bending stress at the outermost fiber of the beam can be found using this formula. Sigma equal to M by Y into I by Y. Sigma is the bending stress, M is the bending moment, Y is the distance from the neutral axis to the outermost fiber, which for circular section is D by 2. I is the amount of inertia. Alright, let's do a simple example. Let's do an example. We have a cantilever beam with the following specifications: length 5 meter, force applied at free end is 10 kN, and cross section circular, the diameter 200 mm. Let's calculate the bending moment and bending stress. Good, Chris. Let's walk through the steps together.